Okay, so we call this as a rational fraction or a rational polynomial as well. Rational fraction or rational polynomial as well. Rational expressions too. So what is the meaning of a rational fraction is that if you have an expression of this nature, which is like px upon qx, wherein p of x and q of x are polynomials, then we will call this as a rational. Then we will call h of x as the rational fraction. So what do we mean by that is like if you have got hx as say 2x plus 5 upon 3x squared plus 6. So here this is a polynomial, this is also a polynomial. And if you divide these two polynomials, what you get is a rational fraction. And the rational fraction of two types. One is what we call as a proper, proper fraction, proper rational. And one is what we call as a improper. And this is important because this will be used for the partial fraction. So what do we mean by a proper and improper rational fraction is that when you can just simply say that when degree of qx is greater than the degree of px, degree of qx is greater than the degree of px, then it will be called the proper rational fraction. And when degree of qx is gonna be less than degree of qx, it will be called the improper one. As in, what has happened here, the degree of this is actually 1, degree of this is 2. So 2 is greater than 1. So this is the proper fraction. So denominator's degree has to be greater than the numerator degree. Then it will be called a proper rational fraction. If it is less or equal, then it will be called an improper. So the number here is was greater, right? Here in this case, we have to have the degree greater. Okay. So it is same thing as in like this should be able to divide this. This is what the numerator should be able to divide the denominator is what will be happening if the degree is higher, right? So that's what is the meaning here. So here you will be looking at the degree of the denominator. Here you will looking at the number. Here we will be looking at the degree. Okay. So doesn't matter if this number is like maybe 5 lakhs into x, and this is just x square as well. Like even if it is say something like a 5 and so many zeros, and then this is x, and then while this is my x square like this is still a proper rational fraction because the degree here is 2, the degree here is 1. Okay, so the number 5,000 is much more than the 1 over here, but it doesn't matter. We are just looking at the variable here, not the constant of proper rational fraction. Okay. And improper is what you can see is that if you have something like 3x square plus 5x plus 6 upon say 2x plus 3. So this is what is your improper rational function. Because here the degree is 2, here the degree is 3. So if the degree is more here, then in the numerator's degree is more, then this will be an improper rational function. The thing is that you can actually convert an improper rational fraction into a proper rational fraction by just dividing. So if I decide to make it a proper one, what I will be doing is that I will be dividing it, right? So this will be like 3x squared plus 5x plus 6. So I'll be dividing it by say 3 by 2. So this will become 3x squared, and this will become 9 by 2x. Then this will be minus minus. This will become x by 2 plus 6. Then I will be dividing it by, sorry, this is x. I'll be dividing it by 1 by 4, multiplying. So this will become x by 2 plus 3 by 4, and this will be minus minus. So this will become 6 minus 3 by 4. So this is protection. Now I can write this expression as 2x plus 3 into 3 by 2x plus 1 by 4 plus I can divide it from this side. So this will be separately. So this will become 3 by 2 x plus 1 by 4. And then plus this will become 21 by 4 into 2x plus 3. So now this is not a fraction anymore. So this part becomes a proper rational fraction. So as here the degree of this is 0, the degree of this is 1. So this becomes a proper one. Okay. All right. So this is the meaning of the proper and improper. Now what we come is to the final frontier, which is what we call as the partial fraction. Okay. So what is a partial fraction is? Basically, it's a way to simplify your expression. If the expression is given, you can actually sort of simplify your uh, fraction into what we call as a partial fraction. So what do you mean? As in, like, if you got a expression like this, say for example, x upon um, say x minus 2 into x plus 2, something of this nature. What you can do is people have figured out that you could write this down as something of this side, as in like a upon x minus 2 plus b upon x plus 2. So what you're doing here is that you are converting this expression into summation of two simple proper rational function, and that is what you're trying to do here. It was here also it has to be a proper rational function. Uh, what do you call it? The proper rational fraction or function is what we're calling, and this has to become this way. What is the use of it is like when you would learn something called an integration, it would be much harder to actually integrate it like this, but rather it will be much simpler to integrate it like this. So we convert this into this, and what we are saying that these two expressions are same. So what we essentially trying to say is that if you take their LCM, x minus 2 into x plus 2, and this will become a into x plus 2. So a and b are constant, so b into x minus 2. Then you can write down this as a plus b into x plus 2a minus 2b upon x minus 2 into x plus 2. So now what we are saying is that as these two expressions are same, it means that a plus b should be equal to 1. Then only it will become 1 into x. And this part 2a minus 2b should be equal to 0. Then only I'll have this 1 into x plus 0. This implies that A should be equal to B, or from here it should come as A should be equal to B should be equal to half. Once you put this half over here, then this expression x into x minus 2 into x plus 2 will become half of 1 upon x minus 2 plus half of 1 upon x plus 2. Okay. So this expression has been changed to this expression actually. Okay. Is what we are trying to do. That we are trying to basically make it a simple expression with only one term over here rather than having multiple terms like this. Okay. So the idea is like they are trying to teach you now partial fraction, but it would be used much later. But so when you would be wondering as to why are we doing this way? Why don't we let it be this way? So we are changing it because it's much easier to integrate it this way than this way is what we will be doing when you learn about integration, right? So so there will be certain rules to it. So what I just told you is one kind of a rule here. There will be multiple rules there. How to convert a given kind of a fraction into a different kind of a fraction is what we'll be doing in a partial fraction. So one of the first type is what we call is that you have got an expression wherein it is what we just did now. So it could be ax plus b upon, well, let's say px plus q. This is the expression first type, which is px plus q upon x minus a into x minus b. And if you have got this expression, it is already proper rational function because what you see is the degree here is 2. When you multiply, you will get the degree as 2, while the degree of this is 1. Now you can convert it into still a proper rational function like this. What you do is you write it down as like a upon x minus a plus b upon x minus b. So what you're doing here is you are making it a proper rational function still, and then creating it more like a simple form. We are saying that it should be equal to a plus b like this. Okay. So this is one form. All right. This way, the same expression, for example, px plus q. So this is px square plus qx plus r, and denominator is actually x minus a whole squared into x minus b. In this type, what we do is still we will be wherein what you're seeing is that the power of this is 2. Okay. So what we will be doing, the rule here is that it would be written as a upon x minus a plus b upon x minus a whole squared plus c upon x minus b. Okay. So what we are saying that you can convert this kind of a fraction, which is still a proper rational function, because here it's degree is 2, here is 3. You can convert it like this. So the thing to note here is that this x minus a whole square. When something is repeating as many times as it repeating, you had it been x minus a cube, you had to repeat it like this. Increase the power one by one, x minus a to x minus a whole square to x minus a whole cube, and so on and so forth. Okay. This is the second type. And then the third type is what I don't know whether they are teaching you. I didn't see that they are teaching you. Okay. So what they are teaching you here is okay, let me write it down. So mm, this will be something of this nature wherein plus qx plus r. Here it is in the denominator it is x minus a, and in the denominator it is x square plus qx plus r, right? So x minus a, and then in the denominator it would be something like maybe say px square plus cx plus d. Now, still this is the what we have here is still a proper rational function. Is it, if it is not, then first when you are wanting to convert it into the partial fraction, what you would be doing is to convert this first into the proper rational function. Then only you will be working further. And in this case, this will be actually written as x1 upon x minus a plus, sorry, and then here it will be written as bx plus c upon bx square plus cx plus d. So I think these are the three rules, and then there will be combination. You can actually work with that. So what I mean, I generally give a rule of thumb to remember is that whenever you are converting this, right? So you look at the denominator and then reduce the degree by one. If I'm looking at this denominator, this is degree is one, so reduce the degree by one, so it will become your 0 degree polynomial. In this case, the degree is 2. If you reduce the degree by 1, it will become the first degree polynomial. Okay. It's here when the power is actually repeating. Okay. When you see the power is repeating, right, x minus a whole square, here the degree of the denominator is 2, while the degree of the numerator is still 1 or 0 actually.